Your lesson today is on direct variation. In this lesson, you will write and graph direct variation equations, solve problems involving direct variation. Your new vocabulary is direct variation, constant of variation, and constant of proportionality. Took this right out of your book. So a direct variation is described by an equation of the form y equals k times x, where k does not equal 0. The equation y equals kx illustrates a constant rate of change, and k is what's called the constant of variation. It is the exact same thing of constant of proportionality. So constant of variation and constant of proportionality mean the same thing, and it's represented by k in your direct variation equation. For example 1, it's all about slope and constant of variation. They want to name the constant of variation for the equation, then find the slope of the line that passes through the pair of points 0, 0, and 1, 2. So your equation is y equals 2x, and you have 2 points here, 0, 0, and 1, 2. So the first thing we're going to do is we're going to use our slope formula, which you remember from the last lesson. It's y2 minus y1 over x2 minus x1. So you should all be very familiar with this. All right, we're going to use 0, 0 as x1, y1, and 1, 2 is x2, y2. So you're going to go ahead and subtract y minus y, which is 2 minus 0, x minus x, which is 1 minus 0. And you end up getting a slope of 2. So the slope and your constant of variation are going to be the exact same thing. They're going to be 2. So the constant of variation for this equation is 2. In example 2, we're going to graph a direct variation. So they give us y equals negative 3/2 times x. There it is. All right, so first thing we're going to do is we are going to find the slope. The slope is negative 3 over 2. All right, whatever's on top is your y, whatever's on the bottom is your x. Then we're going to graph the point 0, 0. Let me grab a pen. All right, so we're going to graph 0, 0. Now from there, what we need to do is from the point 0, 0, we're going to go ahead and use our slope. Because our slope is negative 3 over 2, we're going to move down 3 units and then to the right 2. Let me grab that pen again. All right, so we are going to go down 3 units. And then we're going to go 2 positive to the right. Right there. So right here is our next point. And then your last step is to draw a line connecting the points. So let me grab my line tool. And I'm going to connect those 2 points, and I'm going to keep extending it. And same with this side. I'm just going to keep extending it. And just make sure that it passes through those 2 points. So you guys, I want you guys doing this with a ruler on your homework. That way you do actually have a straight line and you can find any point on the graph. So that's how you would graph your direct variation. All right, our key concept for direct variation, again, it just gives us the equation, which is y equals k times x. K cannot equal 0. The graph of y equals kx always passes through the origin. The slope is positive if k is greater than 0. The slope is negative if k is less than 0. All right, so for example 3, they want us to write and solve a direct variation equation. Suppose y varies directly as x and y equals 9 when x equals -3. Write a direct variation equation that relates x and y. Find the value of k. All right, so the first thing you need to do is you need to write down your direct variation formula, which is y equals kx. Now we're going to plug in the information that they gave us. So they told us that y equals 9, so I plug in a 9 for y, when x equals -3, so I plugged in a -3 for x. Now we're going to solve for k. Because k is being multiplied by -3, we need to move it over, so we need to do the opposite, which is dividing by -3. So we have 9 divided by -3 is going to equal k. 9 divided by -3 is -3, so -3 is going to equal k. And then, when you write out your direct variation, it's going to look like this. Y equals -3x. That would be your answer. So all you have to do is plug in that -3 for k, and then write down your y and your x. All right, now we're going to use that direct variation that we just found to find x when y equals 15. So our new direct variation is y equals -3x. They just told us that y equals 15. So we're going to plug in a 15 for y. So now we have 15 equals -3x. All right, again, we're solving for x, so we need to divide both sides by that -3. And this should be a negative over here. I don't know why it's not. I'm going to replace that. I don't know what happened in the slide here. So 15 divided by -3 is going to give you a -5x. So when y equals 15, x is going to equal -5. All right, so now we have our real-world example 4. We're going to estimate using direct variation. The Ramirez family is driving cross-country on vacation. They drive 330 miles in 5.5 hours. Write a direct variation equation to find the distance driven for any number of hours. So our y and our x now actually are going to have labels. So in words, distance is going to equal rate times time. We're going to let r be the rate, or how fast they're driving. So we know that the distance was 330 miles. That's going to equal r times 5.5 is your time in hours. All right, so we're going to solve for the rate. We're going to plug in the information they gave us. 330 equals r times 5.5. We have to divide by that 5.5 to get r by itself. So 330 divided by 5.5 equals 60. So your rate is going to be 60, and when you write your direct variation, it is going to look like this. Y equals 60 times x, or it could also be distance equals 60 times h. All right? Because we have specific labels, we can write it like that. All right, now we are on part B. We're using what we just learned to graph that equation. The graph of d equals 60 times t passes through the origin with a slope of 60. Again, all of these types of equations with direct variation are going to pass through your origin. So your slope is going to be 60 over 1. It's always going to be y on top, x on the bottom. So when you go ahead and graph it, you're going to put your first point at 0, 0, and then you are going to go up 60, which I know in this graph you kind of have to estimate, and then go over 1. So it'd be right here, you draw a line right past it, and now you can find how far you would drive in any number of hours, because again, it's a constant rate. All right, our last part of this video, we're going to estimate using direct variation. We're going to estimate how many hours it would take to drive 500 miles. And we're using our direct variation equation that we figured out through the problem. So D equals 60 times T. All right, we're going to plug in the 500 for miles equals 60 times T. We're going to divide both sides by 60. And we find out that it would be about 8 1/3 of an hour. And if I could just get the answer to show up here. There you go. At this rate, it would take about 8.3 hours to drive 500 miles. All right, please don't forget, if you have any questions about this lesson, please put them in your Google form so I can answer them tomorrow.